Hello, welcome back to our discussions of the Java ArrayList sorting. So last time we saw how you can teach an object how to compare itself to another instance of the object by implementing comparable. What's the problem here? You can only do one of them. So think of this. If you're writing reports on employee, there might be several ways you want to sort this for the user. Sort by ID, sort by name, sort by salary, sort by hire date. There are many things you can do. And this comparable says, I know how to compare, but there's only one method that you can possibly write. So there's only one comparison method that you can support with this. In order to be able to support multiple comparison methods, a class has to exist outside of the object, and that way you can create as many of them as you need to be able to compare instances of employees' objects. So I've implemented this partially now, but we'll fill it out as we go. Employee compare by ID. So this is a full-up class. It implements the comparator method, right? The comparator interface. So the comparator interface has one method called compare of two employees, right? So let's contrast this with comparable. I know how to compare objects of my own type. Comparator. I know how to compare objects of another type, right? And here we have the other type here. And notice we have two parameters here versus one, because this one parameter had the this here, that is the current object, compared to another object of the same type. Here, this is external, so it needs two parameters in the compare method. But this integer is the same, will follow the same convention. That is, if -1 indicates less than, 0 indicates equal to, +1 indicates greater than. And we're moving here from left to right, right? -1 indicates that employee 01 is less than employee 02, etc. Now, when we go to write this method, we're going to run into an immediate roadblock. This needs access to the fields of employee. Notice that this doesn't. That is, everything's private here, right? We don't have any public methods or getters for these properties. No problem here because this is inside the class. Definitely a problem here because this is outside. We won't be able to access ID, name, or strength, skill, anything that, in fact, that we need of an employee method in order to sort it, because everything's private. So that's one thing we have to kind of negotiate with the designer of the employee class to say, hey, if I want to sort on these methods, you need to expose getters for these fields that I need to sort on. So that's what I'll do here in Eclipse. And I'm just going to select getters and generate. So we'll just be able to read them. We won't be able to set them. We'll just be able to read them, the properties. So this is sort by employee ID. And remember our earlier discussion, we said we should always depend on the standard objects method of compare to write it if it's available. Since this is a primitive, it doesn't really have methods, but we have the wrapper class for the primitive integer. And that has a compare method in it. So that's what we're going to use. So O.1, get ID. O2.getID. And that will follow the convention of -1, 0, and 1. So even primitives have methods already written for them in the wrapper classes, they all do, that has compare methods in them. And we always want to take advantage of already written software in order to do that, because it'll enforce without bug this convention. So now we'll come over and use this new comparator that we've engineered here, employee compare by ID. So our previous sort method used sort employees with no additional parameter, because employees, as we've seen, we taught employee how to sort itself. So collections is happy with us there. Now, to do sort by an external comparator, we need to pass it as a parameter, and here's how we do it. We create an object of that type. So the compiler would actually fuss at us if this didn't implement comparator. So we're guaranteeing to the compiler that we have a compare method by implementing comparator. So therefore, it's satisfied that we've done at least the wiring work necessary to do new compare by ID. So we pass it the object, and then as the sort method works on the ArrayList employees, it will sort them by ID number. Let's try it out. And there we have it. So now we can see that we're sorting by employee ID here. Okay? So here's something that you should note. This is convenient to know. If I return the negation of the compare method, I'll get reverse sort order. That's very handy. So this will flip. The 1 becomes -1, the positive one, -1 becomes +1, and 0 stays 0. So we can flip the comparison, invert the sorted order here. Okay? So with the addition of comparators, now you can invent a new comparator for every method, every way that you want to sort the array. So if you have 10 different reports with 10 different sort methods, you can do it. Next time, we'll see a couple of easier ways to write comparators. Thank you.